Okay, today we're going to talk about the exterior angles theorem. But before that, I want to do example number 3 on the top of page 396, which is a little more of an extension from yesterday. So that problem says the measure of an interior angle of a regular polygon somebody needs to turn their music down. The measure of an interior angle of a regular polygon is 135. The question is to find the number of sides. The measure of an interior angle of a regular polygon is 135. Find the number of sides. Okay, yesterday we said that the sum of the angles for a polygon was equal to n minus 2 times 180. Agreed? Okay. So now, a regular polygon has all the same sides and all the same angle measures. So, if you knew, or if you took this 135 degrees and multiplied it by the number of sides, which is the same as the number of angles, wouldn't that also give you the sum of the angles? Let me say it one more time. If you know that one angle in a polygon, and it's a regular polygon, so all the angles are the same, can't you multiply that measure by the number of sides and get the sum?
Yeah.
Right? Because however many sides there are is how many angles there are. Right? Triangle has 3 sides. It's got 3 interior angles. Quadrilateral has 4 sides, 4 interior angles. So if you know one of the angle measures and you multiply it by the number of sides, it'll give you the sum of the angles. If you take n minus 2 and multiply it by 180, that will also give you the sum of the angles. So if you know both of those expressions are equal to the sum of the angles, which means they're equal to each other. Okay? So now you can solve for n, which is the number of sides for this polygon. So on the left-hand side of this equation, you have to do the distributive property first. So your n times 180 is 180n, and your negative 2 times 180 is negative 360. And that's equal to 135n. If you subtract 180n from each side, then negative 360 equals negative 45n. Divide both sides by negative 45. And 8 equals n. So your polygon has 8 sides. Good? Can anybody give me a name for an 8-sided polygon? Nice. Octagon or a 8gon. Nice, very nice. All right, so that question can be worded a couple ways, right? You could be asked to find the, not like that. Find the number of sides. Or couldn't they word the question, name the polygon? If they asked you to name the polygon, you would need to find the number of sides first and then correspond it to the correct name. Got it? Anybody need to see another example of a problem like that? If you're given one interior angle of a regular polygon. Alright, it's that angle measure times n equals n minus 2 times 180. Alright, move down to the bottom of that page. Get this theorem in your notes right here. The sum of the exterior angle measures of a convex polygon one at each vertex is 360. The sum of the exterior angle measures of a convex polygon, one at each vertex, is 360. That's for all polygons. Their exterior angles sum 360 if you take one angle at each vertex. So let's draw this triangle here and get a visual of this. Alright, we got triangle ABC here. And let's make sure that you understand what an exterior angle is. An exterior angle is formed by an extension of a side and its adjacent side. An exterior angle is formed by an extension of a side and its adjacent side. So if you take side AB, do you see how this is its extension? This yellow piece is its extension, and BC is its adjacent side. So there's an exterior angle. Side BC, this is its extension, and CA is its adjacent side. So here's an exterior angle. The extension of side CA and side AB form this third exterior angle. Yellow plus green plus blue equals, that's a question, equals 360. Very good. Alright, that's one exterior angle at each vertex. The sum of the exterior angle measures of a convex polygon, one at each vertex, is 360. Everybody see that? Alright, while we're here, I'm going to extend side AB this direction and side AC this direction and side CB this direction. Do you see this red angle here and this red angle and this red angle at vertex B? Those three red angles, do you see how they are all formed by the extension of two sides? They are not exterior angles. So scribbly red, not exterior angles. By definition, an exterior angle is formed by an extension of a side and its adjacent side. These red angles are formed by the extension of two sides. So please don't confuse those. The red angles are not exterior angles. They are just vertical to these interior angles of this triangle. Everybody good with that? Look at the top of page 397. We're going to do an example problem. So we got this five-sided shape right here that goes kind of down and to the left a little bit. Then we got a horizontal piece, a diagonal piece, another diagonal piece, and then we're going right there. So it's a 1, 2, 3, 4, 5-sided shape. It's a pentagon. Each exterior angle is represented by an expression. What do those five exterior angles have to add up to? They got to add up to 360. So if you're asked to find the measure of each angle, you have to solve for x and substitute. So these five angles added together have to equal 360. So let's add or combine some like terms. We got a 2x plus a 3x plus a 6x plus another 2x and a 5x. You got 4, that's 9 and 9. So you've got 18x. And then if you combine the whole numbers, you got a negative 5 plus 10 minus 5. The two negative 5s give you negative 10. And if you combine that with a positive 10, you get a 0. So your 18x is equal to 360. And you can divide both sides by 18. Your x equals 20. But the question was to find the measure of each angle. So now you go back and substitute. I'm going to start with the 2x and go counterclockwise. So if x equals 20, 2 times 20 is 40. 5 times 20 is 100. 2 times 20 minus 5. 40 minus 5 is 3 times 20 plus 10. 6 times 20 minus 5. Alright, so those are your 5 exterior angle measures. Does anybody have any questions on either of the problems we did today? The exterior angles problem or the finding the sides problem? Alright, your practice for today is right there, red font with a blue frame around it.